It's been a pleasure spending a little bit of time with you the last few days. Really enjoyed some of the talks, and dry ice today was interesting. We use dry ice in our business, so that was interesting to see. I hadn't seen the liquid dry ice that Nancy uses, so that was really interesting to me. I didn't prepare a presentation. Randy didn't ask me to speak before, but as I was sitting there and talking with him about a few things, I thought there might be a couple of things that you would be interested in seeing. So I wanted to share a couple of different things. A little bit about, I do document recovery with BELFOR, and document recovery typically, it usually involves water. So when there's water in paper, it gets wet, you have to recover it somehow. So I do freeze drying, and we have freeze drying capabilities in several locations with BELFOR. And I just thought I would walk through. I've got a video that shows the freeze drying process, and wanted to walk through that with you a little bit and explain. If some of you may be very familiar with it, some of you less so. So I thought I would just show the video. I'm going to stop it at a few points and explain some of the details of the freeze drying process. And then the other thing I'm going to show is a shrink wrap application for when buildings are damaged, like with hurricanes. If part of the roof is missing, or you have some of the building envelope that is damaged, you can actually put some very heavy-duty plastic and heat shrink it in place and protect all the contents, protect the building, and potentially bring in dehumidification or do other things that you need to do with just a temporary protection. It's very difficult otherwise to do anything else inside the building if you can't protect it from the holes in the roof or the windows and things like that. So those were kind of the two items that I wanted to address. And then if we have any time at the end, I thought I might address gamma radiation as a sterilization treatment on paper. We typically wouldn't do that for culture materials, but for a lot of business records, it seems to make sense. So if there's interest in that, I can address that one as well. So, all right. So these are freeze-dry chambers, and basically they're just big pressure vessels, and they have all of this ribbing on them so that they don't collapse when you pull a vacuum inside the chamber. So it's got to be a very strong box with all of the supports on the outside to keep it from crushing like a beer can whenever you pull a vacuum inside the chamber. So these are the chambers themselves. So that's what we put. These racks you can see here where the door is open, that's where the boxes go that are full of the wet documents. Actually, and they're frozen when they go inside the chamber, and then you put them on the racks and then wheel the racks into the chamber and then close the door and pull a vacuum, and then that's how you start the freeze drying process. Here's kind of the nuts and bolts of what freeze drying is. This is a phase diagram for water. So on the y-axis you have pressure, temperature on the x-axis. So here is the triple point of water, and that's the key point there, because anything over here is ice, anything in this area is liquid, and anything over in this area is gas. So you can go from ice to liquid to gas at this pressure and temperature. At this pressure, as you increase the temperature, so let's say this is normal atmospheric pressure where we are. So you can see that we're solid ice. Then at 32 degrees or whatever it is, we will melt and become a liquid. And then at some point it will boil and become a vapor. So as these lines converge, there is a triple point at which, at any pressure below this level, if you can see that no matter what temperature you go to, you can never reach the liquid phase. So you're actually sublimating directly from ice to vapor if we're below the triple point of water. That's 4.57 millimeters of mercury, which here in this room we're at about 750 millimeters of mercury. So it's very, very low pressure. It's almost a total vacuum, but that's what we do inside those chambers, is we create that total vacuum so that we're sublimating and going from ice to vapor. You might ask, why do I care? Well, the reason is because liquid is what damages paper. Liquid is the problem with paper. It lets it degrade to paper mache, it lets mold grow, it does other problems with paper. So we're going straight from ice to vapor so that the condition of the paper as it was when it went in the chamber is going to be the same once it's dry. It's just going to be dry. So if it was already damaged, we don't reverse the damage, we don't fix it at that point. We're simply drying the paper in the least damaging means possible. So we'll move forward now. And I'll show you kind of a visual representation of what freeze drying is. Okay, so I'm going to explain the setup here. We're taking this picture through a 2-inch plexiglass window because these beakers, the beaker on the right and the thermometer on the left, are inside the vacuum chamber. So you can see atmospheric conditions exist inside the chamber. It's 757.9 millimeters of mercury here on the right. You can see the pressure level here. You can see the temperature here, and this is the temperature of the liquid in this beaker, and this is the temperature of the air inside the chamber. So what I'm going to show you is that the temperature of the air inside the chamber never changes, while this water will freeze when I simply pull a vacuum on it, because from my diagram it showed if I go below the triple point of water on the pressure line, the only two phases that can exist are solid and vapor. So I'm actually going to freeze that water simply by pulling a vacuum in the chamber. So, and these will demonstrate that as we move forward. Does that make sense? All right. So it's got we got a little bit of a time lapse going here. So you'll see we're down to 655 millimeters of mercury. Temperatures are consistent. They're staying at about 70 degrees. Still at 146, so we're getting pretty low in pressure, 17.4, but still the temperatures are pretty consistent, okay? We're at 4.53, so actually it can actually go slightly below the triple point before it gets too violent, and it's going to actually boil and then freeze. So you can see the temperature has started to drop on the thermometer that's in the beaker there, so it's down to about 60 degrees. And the one in the airstream is close to 70. So the actual temperature of the water has started to drop. And that's just water with food coloring, so you could see it. So we move forward a little bit. We'll turn it into a video here, I think. Okay, so you can see it's starting to boil at room temperature. The temperature's dropped a little bit, but it hasn't really drastically dropped. So we're now below the triple point, and it's going to start. Okay, so now its temperature is drastically dropping as it freezes because of the pressure inside the chamber. Air temperature is still constant over here on the left. Air temperature is not changing. Simply the temperature of the liquid, because of the pressure, is below the triple point of water. So now you saw it dropped well below freezing before the ice formed on the surface. So we're now down to about 20 degrees. Ice has formed across the top, and it will continue to freeze solid inside that beaker. So it's freezing, and what happens is it will freeze solid, it will stay at low temperatures, and then that ice will sublimate, it will pull away from the thermometer, so then the temperature will come back up equal to the air temperature. But in a short period of time, all of the ice will be gone outside from that beaker because it will all sublimate into the air. So I get a lot of questions, what refrigerant do you use inside your chamber, or how do you use liquid nitrogen, or what do you use to freeze dry? And the answer is nothing. It's simply a function of pressure. So we pull a vacuum below the triple point, and then we make sure we keep it there. We actually add some heat normally to the documents, and then that speeds up the rate of sublimation. We don't do that with cultural materials. There can be some concern about accelerated aging of paper and things like that, so we can turn off the heat. We have complete control of that. But for normal business records, we would add some heat to the chamber, and that speeds up the drying process by about 3 times. Okay, so that's what freeze drying is. That makes sense. Anybody have any questions on that? Yeah.
The freeze drying units that you have, that's only in Dallas or in Fort Worth?
We have 5 facilities in North America, 2 in Canada, 3 in the lower 48 states. So 1 is in Exton, Pennsylvania. We have 2 chambers there. We have 1 in Hayward, California, and just in Oakland. And then we have 5 chambers in Fort Worth. So I have 3 fixed ones and 2 mobile chambers in Fort Worth. So we have the largest capacity at my facility in Fort Worth, but we do have 5 locations in North America with freeze-dry chambers. And that's just one aspect of the freeze-drying process of paper document recovery. There may be cleaning needed. There may be, as I mentioned, gamma radiation is a potential treatment if they've been in floodwaters with sewage and things like that, and people have concerns there. But normally we wouldn't use gamma radiation for cultural materials unless somebody has a really concern about the health effects. It does sterilize the documents, but it also degrades the cellulose. It damages the cellulose through the gamma radiation process. But go ahead, Bill.
I'm very glad to hear that you're not adding heat for cultural property, because having been involved with some materials that had been vacuum freeze-dried and they added heat, one of the things that I witnessed was you could actually see almost like tree lines, tree rings on the book paper, because they must have been adding heat, intermittently.
Right.
And it's always been a concern of mine. In fact, I wanted to speak with you directly about that. And I'm very glad to hear that you don't add heat for these materials.
Right.
Thank you.
Yeah? So, any other questions on the freeze drying? So like I was saying, the other, some of the other aspects, and one of the things, another component of document recovery is the sterilization process from things that have been in floods. So you have, potential bacterial contamination, viral, fungal contamination, all sorts of things that can cause problems, both health and safety related and visually to the documents. So gamma radiation is one treatment that we use routinely for business records. Again, typically, we don't recommend that for any cultural materials also, because again, that does damage the cellulose. We know that gamma radiation causes breakdown of the cellulose bonds. That's how it kills the organisms that are in the paper. It actually disrupts their DNA and kills everything, so that sterilizes the document. One good thing about it is that you can put a sealed document inside the it's a nuclear radiation, use cobalt as their radiation source, and you run it in front of the radiation source back behind a bunch of lead walls and concrete walls, and then once it's out, it has a dosimeter, so it measures the actual amount of radiation that it received, so that you can ensure that everything inside that box is completely sterile. And so you have a level of confidence that everything is safe to handle from a health and safety perspective. And it's very good for things with retention schedules. So if it's something that's going to be disposed of in 20 years, the level of damage that gamma radiation causes isn't going to cause it to deteriorate in that period of time. But if it's archival or something that needs to be kept forever, then I don't recommend that process. Has anybody deal with gamma radiation? Is that something that you've dealt with or know about? Yeah. I would welcome any feedback if you've got opinions on any of that stuff. So. Okay, well, the other thing I wanted to let's see. So the other thing I was going to show you was a few pictures related to the shrink wrapping of a building, and this actually happens to be Dartmouth College. We've got a number of different examples. But when a building has a fire or some other hurricane damage, roof damage, some type of damage, and part of the roof is missing, before you can really do much to the building in terms of, protecting the contents or doing work inside the building, dehumidifying the building, you need to secure the building envelope. And so this is a relatively unique way of doing that, and the shrink wrap is kind of a medium-term solution. If you're just going to be a few days before the roofer gets back and can get their materials and can get it on and secure it, then shrink wrap probably isn't the best solution. It's more for something that may take a few months. Maybe it's a particular type of material that you've got a lead time, or you have to have some architectural work done, or it's a major repair that can't be done quickly. So if that's the case and you need to secure the building and start work inside, then you have to have some way of securing that building envelope. So that's what we've done here, is we've started some work with putting some plywood to cover some holes and things like that. We'll move forward a few slides here. I'm going to come through these relatively quickly. As you see, some of the roofing material is gone there off the upper left side. Here we can see the roofing is gone. This is actually some of the shrink. It's a white, very heavy plastic. It's like a 12 mil plastic that is heat sensitive. So when you heat it, it stretches and shrinks. It actually shrinks into place. So that's what it looks like. So this section of roof was damaged, and you can shape it to form anything. It comes in sheets, but you can heat it and weld it together basically. So you can conform it to any shape that you need. So I just thought this might be of interest to you for, potential reference if you have something. I was talking with Randy about earthquake damage and what do we do if there's an earthquake and you've got 50 buildings damaged and you need to secure the contents or you need to dry something out, then this is a good application for it. So you can see, you've got some puckers there, but if you just use the heat gun on this, it stretches it taut and will shed rain, will shed snow. We've had them in place for as long as a year. If it requires, there may be some other circumstances that they can't start the repairs immediately. So it may require a little bit of maintenance. If there's high winds and maybe a seam breaks loose or something, you may have to do occasional repair to it, but for the most part, we've had them in place as long as a year. So here's showing the section of the burned roof again. Pretty large areas. You have to do a good bit of framing in some cases to support the plastic. You can't just have, a 60-foot expanse and you put plastic on that, then it's going to bow down, and then if you have rain, it probably will not all run off. So in many cases, you have to do some temporary framing, and there's this nylon webbing that you can use to support as well. So you don't really have to frame it out great, but you do have to do some level of work to make sure that you got enough support for the shrink wrap. So that's it rolled out on the ground, and typically you'll kind of put it together on the ground usually, and then lift it up with the lift equipment and drape it in place once you've got it relatively shaped on the ground level. And that, just to point out, that's probably 10 folds of paper. 10 folds of plastic, so that will roll out. That's probably a 30-foot wide section once you unroll it completely. It comes in plastic rolls that are a variety of sizes, but that range from 20 feet to 60 feet in width. You can buy it in a number of different sizes, depending on what you're dealing with. So I'll just go through a few of these slides, show you some of the work that's required. The scaffolding to get access to all those damaged areas. And you can see there's not much other way to secure a building with damage like this unless you were to actually rebuild the wall and the roof, and a lot of damage there that you can't really seal up the building envelope any other way. There's the heat on the metal roof. So I just thought that might be something that could be of interest to you.
How long did it take to do that work?
I wasn't on this job particularly, but I can tell you that it would normally take us, that was relatively extensive, so it probably took us about a week from start to finish. Yes.
And how easy is it to remove?
It's very easy to remove. You can cut it with a box knife and peel it off. Obviously you have some framing and things that you'd have to remove. And in some cases we've actually had it above the surface of the roof so that work could be done underneath it, so that you could actually leave it in place while some of the repairs were going on underneath it, so that the building was protected while some of the repairs were going on. We have to understand what the procedures are going to be so that we can build it that way, but if that's going to be something that's needed, we can actually elevate it a little bit and then allow some of the work to go on while it's still in place. Yes?
How is it secured around the edges?
There's 6-inch tape that, and then quite often we will use furring strips that will roll it in and then secure with screw fasteners along the sides of the building. If it's masonry, we may have to use some masonry anchors, things like that. It does need some pretty secure connections. We actually had one case where there was a little bit of it was a flat roof with a knee wall on the edge, and the owner, the client, said just secure it to that, and our guy was saying, well, it really puts a lot of tension on that. We'd prefer to go down the side of the building. No, just put it there. So we did, and we shrunk it in place, and it snapped the knee wall off. So yeah, it's pretty secure, and it does take quite a bit of tension. Yes?
Maybe two questions. But the first one is, with something like this, if you have a big expanse that you're covering, and then you have this white plastic over the top instead of the roof, obviously it's better than no roof at all, but have you noticed, or do you know if the temperature and inside is affected? I can just sort of imagine the sun shining down on this white plastic roof all day.
Temperature is affected. Typically, it's, you don't have the insulation factor that you would have normally had in a building. So you got a piece of plastic there. We don't see, the reason it's white is it does reflect the heat in the summertime. So it reflects heat well, but it's probably a good bit colder in the wintertime because it doesn't have much insulation characteristic. So you would have to have maybe some additional heat inside the building in the wintertime. And you might have to affect the air conditioning in the summer, but yes, it does impact that.
And then for these clients who you've worked with in the past, do they already contract with you for other things, or is this something that's sort of available to anybody in an emergency, no matter where they are?
It's available to anyone. We do have a number of clients that we have ongoing relationships with and contracts with, but even if we don't, then it's available for other clients. Yes?
For heating the plastic, are you using something more industrial than just like an average heat gun?
We are actually. We've got propane fired guns that actually have a flame. It's kind of a flamethrower, basically, is what it is. And you have about a 6-foot extension for the most part, so that I can stand here and work on a ground level, something at ground level, and it's a propane-fired heat gun. Yeah, so it's pretty heavy. You have to be careful not to burn a hole in the plastic. If you leave it in place very long, you're going to burn a hole. You can repair the hole, but you're going to burn a hole in it if you leave it in place too long. Yeah, that's right. Okay? All right, thank you.
Thanks, Kirk. We could have used that in 2009 in Juneau when we lost the covering on the roof there. Could have avoided that whole flood that Seth was talking about.